Now let's see a situation where we add the element in a certain index or to a particular index. So in case of linked list, there is nothing called as indexing internally. In case we have to make use of index, then we need to start counting the index. That's the only way that we can do. So what exactly this means to say is, there will be a method. The name of the method will be add, which will accept one index value as well as the element. So if it says the index is 2 and the element is 25, or index is 3 and the element is 25, so it should add the element in index 3 and the element that it is adding is nothing but 20. So if I have to pictorially show you, this is how it would look like. So over here I have my linked list. Now by default you can clearly see there is no indexing, but I would like to write index values for this. So if starting index would be 0, then goes on moving ahead. Now what I need to do is, I need to add an element at index 3 and the element I want to add is 23. So how I will call this, I will call like this, add then 3 comma 25. So 25 will be added in index 3. Now how can I do this? Very simple. You can clearly see I want the element to be added in index 3 means it should be between this and this. So the element that I had will come in between. Now how can I do this? Simple. The concept is very simple over here. The first thing that I need to do is I need to create a new node. Once I create a new node, all I have to do is I need to break the connection which is over here. The link which I created over here, it should be broken and it should start pointing to this. The element which is already present over here, that's 30, should point to the new node. And what should happen is the new nodes next should start pointing to the next. So this, if I do, it means to say this will be in index 0, 1, 2 and the new element has come at index 3 and the last element will be at index 4. So this is what exactly is expected. Now let's see how we can write the code for this. So what is that we need to do to achieve all of these things? First thing, we know very well that I need to create a new node. So first let me create a new node. Once I am done with creating a new node, I will give a reference for this and the reference for this is nothing but 10. Now after this, what I need to do is, I need to make the connection, means the next of this particular node should start pointing over here and the next of the new node should start pointing to the next node over here. Now how can I do this? To do this, then definitely I need some extra references. So there is no one who is pointing to this particular node as of now. So I need someone who will start pointing to this particular node. So I need a reference which starts referring this node. Now how can I do that? Very simple. We have seen a logic by taking a temporary variable called as current. We will move the current from here to here and then we will do this. So how to move current from here to here, we will see that later. But once the current is moved from here to here, what is that I need to do? Very simple. What I need to do is, I need to break the connection from here and place it over here, and one more is I need to build the connection from here to here. But which one should I do first? You have to see the problem over here very carefully. If I break this connection, then this node gets removed from here. So I should not break this connection first. First I need to establish the connection from the new node to this particular node. So new node is already known as temp. So temp is referring to this. So the temp.next should start pointing to this node. Now how can I get the reference of this node? The reference of this node I can easily get by saying, since current is pointing over here, current.next is nothing but this node. So what I need to do is, whatever is there in current.next, so current.next is this, which is the reference of this node. So current.next, whatever is available, that particular thing I need to store in temp.next, means over here. If I store it, automatically this will start pointing. So all I have to write in code is temp.next is equal to current.next. So if I do this, this connection gets established. Next, after this, what I need to do is, I need to remove this particular connection and establish the connection from here to here. So basically, in current.next, what I should place it, I should place whatever is there in temp. Because temp is referring to this node. So the reference of this node should be available in current.next. So how do I say that? I say that how do I say that? It's very simple. Current.next is equal to temp. If I write this, then the second operation also will be. But the major question over here is, how can I move the current all the way from here to here? For this particular thing, you know how to move. You can clearly say current is equal to current dot next. But how many times should I do that? Very simple. You can clearly see over here. The index that I need to place the element is at index 3. Now, how many times I need to move the current? At starting, current will be over here. So, this is 1 time, this is 2 times. So, basically 2 times I need to move the current. Now, how do I write the logic? I write the logic in a simple way. First, let me write a while condition. So, before I write while condition, I need to initialize one more variable because I need to keep track of how many times I am moving this. Means I need to keep track of the count, how many times I am moving the current. For that particular reason, I will introduce a variable called as count, where the value of count will be 0. Next, what happens is very simple. I will write one while condition, and inside that while condition, I will say count is, I need to keep track of count. So, what exactly is the condition, we will see later. But what I will do is, I will come inside and I will say current is equal to current dot next. So, at starting, current will be pointing over here. So, basically, I need to say current is pointing to the head. And after that, what happens is current moves 1 step ahead. So, 1 step when it moves ahead, I will change the value of count from 0 to 1. So, basically what I need to do, I need to move the current and increase the count. So, that's what I will be doing over here. Current is equal to current dot next and count is equal to count plus plus. Means basically I am increasing the value of count. So, once I have done with this. Next, what I need to do, current is pointing over here. Again, I need to move to here because this is where I want the current to be. So, what I will do is, I will say current is equal to current dot next. So, again I am repeating this operation. So, current goes to here. Next, after that, what I will do is, I will say count plus plus. So, the count value increases. Now, what is the count value? The count value is 2. Now, from here, I should not move the current. Means I should stop over here itself. So, basically, till when should I move the current value if you ask me? Till the value of count becomes 2. So, what I need to do is, I need to say the count should be less than 2. But the question is, how can I get this 2? Now, why did I get this 2 is because I am placing the element in index 3. In case if I was placing the element in index 4, I would have got it as 3. In case if I was placing the element in index 5, I would have got it as 4. So, that's how it is. So, basically how I got this 2 is nothing but the value of index minus 1. So, what I need to do is, I need to say the value of count should be less than index minus 1. So, if I do this, the problem is simple, and this is the code that I need to write to place the element at a certain index. So, I hope this is completely clear to you. But there is one more problem in this. This is one scenario, but there is one more scenario. And what is that scenario if you ask me? It's very simple. What if I have to add an element at index 0? So, if I say index 0 and if I run this code, it will definitely not work, it will definitely fail. Because over here I am actually making use of the previous node as well. But in this particular code, I am making use of previous node. But in case of index 0, there is no use of previous node because there is no previous node when it comes to adding an element to index 0. Now, what I need to do if I have to add element to index 0, very simple. We have already written a method called as add first. So, that's the method I need to call. So, all I need to do is, I need to check, is the index that I am placing the element, is it at index 0 or what? So, if the index is 0, then I will call add first and pass the element, or else I will run this logic. So, I hope this particular thing is completely clear to you. So, let's go and write the code for this. Now, let's write the code to add an element at a certain index. So, first thing that I need to do is, I need to go and implement the method inside the linked list class. So, let me take you to the linked list class. So, inside the linked list class, we already have print linked list, add and add first. Now, all that I need to do is create one more method called as add. So, I will say void, and after that I will say add. Now, this is also add, but we are overloading the method. So, I hope you already know what overloading is. So, all that I need to do is, I need to accept an index. So, I will say int, and I will just say I, or you can say it as index as well. Let me mention it as index itself, and after that element I will say int and element. Great. I will open and I will close this. Now, what exactly, if I scroll it up, what exactly I need to do, what is the code that I need to write inside this is very simple. First thing I need to do is, I told you at starting, the index might be 0 as well. So, what I need to do is, I will check if the index value is 0. I will check if the index is equal to 0. Index is equal to 0. So if index is equal to 0, it clearly means to say that I will need to add the element to the first. So we already have a method called as add first over here, so I'll just directly call that method. So I'll say add first. So add first, and what I need to pass is nothing but the same element that I have accepted over here, so I'll say element over here. So this is all I have to do. So basically I am not writing the code again, rather I am utilizing the same code what I had written earlier. Now after that I will come to the next line, I will say else. So if it is not index 0, only then I need to write the logic that I told you. So the first thing that I need to do is I need to create one new node called as temp. So I will say new node, and the element present inside that is nothing but the element, so I will say element, and I will give a reference for this, and I will name the reference as temp. Next I will come to the next line. I need one variable called as count, which will keep track of how many times I need to keep shifting the current. So what I will do is I will say count is equal to 0. So int count is equal to 0. Int count equal to 0. I'll come to the next line. Now what I need is I need to refer that refer a particular node. For that I need one reference called as current. So what I will do is I'll create a reference called as current, and the current will be actually starting pointing to the first node at starting. So what I'd like to do is whatever is there in head I will paste it in reference. So how I will do that is current is equal to self dot head. Sorry, this dot head. This dot head. I will put colon, and current is also of type node, so I will say node. Great. Now I will come to the next line. Now over here I need to write my actual logic. That's nothing but I need to move the current to a certain position where I need to add the element. So what I will do is I will say while count is less than, and I need to say the index minus 1. Next I will come to the next line. And over here what I need to do is very simple. I just have to move the current to the next. So how do I move the current to the next? Current is equal to current dot next. So current equal to current dot next. So once I am done with this, the next thing that I need to do is I need to increase. So how many times I move this particular thing, at the same time I need to increase the count as well. So I'll say count is equal to count plus 1 or count plus that. Yes, that's all I have to do inside the while loop. Once I am done with this particular while loop, one thing is very clear, the current is pointing in such a position where I need to add the element. So basically it will be pointing one node before that. So all I have to do now is just two statements. One is temp.next is equal to current.next. Temp.next equal to current.next. And in the next line, I'll say current.next is equal to temp. Current.next equal to temp. So to understand the code, make sure that you are seeing the diagrammatical representation and then you are understanding it. Or else I would also suggest you to implement in a piece of paper and see how exactly it works, so that it becomes easy for you to understand. So this is all the code that I had to write. Now what I need to do is I just have to go to the main method. In the main method, let me comment these two lines, add first and add. Okay. Next, after that I will come to the next line, and over here what I am going to do is this particular element is in 0th index, this is at 1 index, this is at 2 index, this is at 3 index. So just let me put a comment beside this by saying 0, then 1, then 2, then 3. Yes. Great. Now what I need to do is in index 2 I need to place that element. So automatically this will go to index 3 and this will go to index 4. That's what I need to do. So what I will do is I will call ll dot, then add, and I will pass the index value. So the index value is nothing but 2 and the element is nothing but 25. Now if I do this and then print, so what exactly should happen is 10 should come, then 20, then 25, then 30, then 40. 10, 20, 30 and after that 25 and 40. So that's what should happen. So let's execute this and check if we are getting the expected outcome. So you can clearly see this is at index 0, this is at index 1 and 25 is at index 2, and I am saying place the element in index 2. So I hope this is completely clear to you. Now in case if I say place in index 3, automatically it will come to index 3. So what I will do is I will say place it at index 3. and if I execute this, the element would be available at index 3, and you can clearly see this element is available at index 3. So 0, 1, 2 and this is at index 3. Now I need to check whether placing in index 0 also works or not. So what I will do is I will pass this as index 0 and I will execute it. And if I execute this, you can clearly see it has come to index 0. So it works in all the particular index. But there might be some other cases. Let's assume I don't want at index 0, rather I want at index 10. I want this at index 10. Now, if I execute this, let's see whether it works or not. It clearly doesn't work because there are no so many elements till index 10. So let's see what is the exception that it's giving. It's giving me null pointer exception. But why exactly is it giving me null pointer exception? Because clearly what exactly is happening is in line number 70, inside the add method, one exception is happening. So line number 70, let me go and see what exactly is happening. So if I go to line number 70, over here, what exactly is happening is current is equal to current.next is what it's saying. Now when it's saying current is equal to current.next, here this would have already reached null. So you are saying null.next. So when you say null.next, you will get null pointer exception. But as a user, if he enters 10, what should happen is it should say index out of bounds exception and not null pointer exception. Now the question is, how can I do this? Now this is when the language fundamentals comes into picture. This is why you should know the complete language and then learn the data structures and algorithms. So in this particular case, you should know something called as exception handling, and if you know exception handling, this job would become easy. So all that I have to do is, over here there is a possibility of getting null pointer exception. But you should not say to the user saying that it is null pointer exception, rather you should say it is arrays index out of bounds exception, because he has given you the wrong index. Now how do I say that? Very simple. All I have to do is, I will scroll on top. The whole code, whatever I have, the whole if else thing, I will put inside a try block. So I will cut the whole code. I will create a try block. Yes. And I will paste the code inside this. Now exception E, I don't want exception E. Rather what I want is, I want null pointer exception, because that is the exception that I used to get in this particular line. So I'll say null pointer exception. So I am handling only null pointer exception. So null pointer exception I handle. I will delete this particular line. And over here, what I need to do is, I need to handle it. But exactly what should I do? I should not handle it. Rather what I need to do is, I need to give it back to the user, saying that you are getting array index out of bounds exception. Now how do I say that? Very simple. If I have to say that you are getting array index out of bounds exception, I need to say throw. So I will say throw, and after that I will say array index out of bounds exception. And I will put back this. Let me just press on this and check what exactly is the error. So basically what exactly is happening over here is, maybe we'll have to handle, we'll have to throw, once you say array index out of bounds exception over here, I need to make sure that it goes to the main method as well. So what I will do is, I will say throws, and after that I will say array index out of exception. I will say throws, array index out of bounds. Still I am getting this. So let me put parenthesis and let me say new as well. So I'll say new array index out of bounds exception. Basically I am trying to create an object of array index exception, and then I am throwing. And you can clearly see now you don't have the error. So basically what is happening is, you got null pointer exception, it's handling it, but exactly is it handling it? No, it's not handling. Rather it's throwing some other exception. Means it's saying that you are not getting null pointer exception, rather you are getting array index out of bounds exception. So this clearly means to say you are not handling the exception, you are giving it to the method which called it. So which method called this particular method at the main method as called. So if I go to the main method, so over here you will get array index out of bounds exception. So let's check whether we are actually getting it or not. So if I execute this, you are getting array index out of bounds exception. But the problem over here is, I don't want array index out of bounds exception, because we are not making use of array. So what I want? I just want index out of bounds exception. Is that possible if you ask me? Yes. there is something called as array index out of bounds exception, and there is something called as string index out of bounds exception. So both of this parent is nothing but index out of bounds exception. So what I will do is I will go and change it to index out of bounds exception rather than array index. So what I will do is I will cut this array from here. So it's clearly creating this one. So I will go on top as well, and over here also I will remove this. And now if I execute this, if I bring this, you can clearly see java.lang.index out of bounds exception. But if you want something called as linked list out of bounds exception, then you will have to create a new class, and then you have to inherit this particular class to that particular class and implement it completely. But if you don't want to complicate it, this is how you can write. So this is how you can actually make use of different topics in case of DSA as well. But usually in the interviews, they won't be asking you to do this when you are actually writing the code. But in case of face-to-face interview, they might ask you to do some modifications in the code, and that's when they might give you some scenarios like this. So make sure that you are capable of doing all of these things, and to be capable of doing all of these things, you should first know the complete core Java, and only then you can learn data structures and all. If you have enjoyed this video and would not like to miss any of our videos, hit on the subscribe button and click the bell icon.